I wanted to make a video for you for the first problem on the regression activity worksheet. And if you'll notice, I've typed out the data that it gives you on that worksheet. It says, using the data below, find the equation that best describes the data, then make a prediction about the population in 2035. So notice that because you have years, you have to make this first data value either 0 or 1 instead of 1900. And so then you would count up from there. So if you made this value 0, you would say 1910 is 10 years after 1900. So that would be 10. This would be 20. This would be 30 years after 1900, 40 after 1900, 50 after 1900, 60 after 1900, 70 after 1900, 1980 would be 80 years after 1900, 1990 would be 90 years after 1900, 2000 would be 100 years after 1900, 2010 would be 110 years after 1900, and 2015 would be 115 years after 1900. And normally I would let that value be 0 because it's the easiest. Okay. Well, there is a slight problem with this though, because if you notice, it says try these 3 regressions: linear regression, exponential regression, and natural log or logarithmic regression. And I'm going to do the logarithmic one first, and I'm going to show you what happens if I leave this data the way it is and do the logarithmic regression. So if I do the logarithmic regression in my calculator, it's a plus b ln x and 1. And so if I do that, I get this little like red with an triangle with an exclamation point. And if you typed this data in your calculator and you went over to stat calc and you went down to number 9, which is the LNREG or the logarithmic regression, it would say ERR domain, and it would say quit or go to. Okay, so the reason that it says that is because you cannot take the natural log of 0. The natural log of 0 is undefined. So anytime you're trying to do a logarithmic regression, you cannot have an x value of 0 in your data. So in this case, even though it might be easier to let x equals 0 and count up from there, I'm going to have to let my first data value, if I want to look at a logarithmic regression, be 1. And so then each of these would go up by 1 because 1910 is 10 years after 1900, but 1900 is now 1. So you would need to do that anytime you're asked to find a logarithmic regression, because you can't have a 0 in the domain or in the x values for the natural log. Or if you look at your scatter plot and you see, okay, I think this looks like a logarithmic curve, then you would need to make sure your years were at 1 before you tried the logarithmic regression. So if I do that, I see, okay, now that works, but I get an r squared at 0.7459. That's not a particularly good fit for this data, looking at the scatter plot. So when I look at the scatter plot, I want to see, okay, is a line a good fit or is an exponential curve a good fit? So if I do now an exponential graph, it would be a times b to the x, and then put my little 1 in there. And so again, if you see this one, you see r squared is 0.8898. That's better, okay, because it means the line more closely fits this data. And now let's try linear regression for this data. So in this case, since I see this is a positive correlation because this one is increasing, the other is increasing, I see R is 0.971. That is a strong linear correlation. So I'll say, okay, in this case, my linear regression is the best fit for this data.